Hello everyone, welcome to the Quadratic IGCSE Additional Mathematics 0606 course. This video will cover the second chapter, which is quadratic functions. So let's get started. The first thing that is mentioned in the syllabus is finding the vertex coordinates and basically if it's a minimum or a maximum. And so it's a very simple way of determining if it's so minimums have the coefficient of x squared being positive and maximums have the coefficient of x squared being negative. And then there's two methods for finding the coordinates of the vertex. The first one is completing the square, which is this process here. Essentially what you do is you factor out the a to get it in this form. You then divide the coefficient of x by 2. And so because this works this way, essentially if I say I have x plus 2 whole squared will be x squared plus 4x plus 4. So so this is basically x squared plus 2x plus 2x plus 4, right? And so essentially what we're looking at here is just this number and then just that factoring basically. So that's the whole process. Just we're gonna reverse. We're gonna go from this one to this one instead of going from this to this. So what this does is that then you multiply the a minus b over 2a whole squared to get this, and that's essentially the vertex point. It looks a bit messy, but if you look at the example here, we factor out the 2 to get this. 3 by 2 is 3 by 2 minus 9 by 4, because we just need x plus 3 by 2 whole squared, which is x squared plus 3x plus 9 by 4. We want to subtract that because that's extra, and then you multiply that. 7 minus 9 by 2 is 5 by 2, and so your vertex coordinate becomes the negative of this, which is minus 3 by 2, and then the same thing here. The second method involves differentiation, which is in the further chapter, but essentially what you do is x is just minus b over 2a for the vertex x coordinate, and then you just put that x value back into your function to get the y value. So here you see differentiating gives minus 6x plus 10, so x is 10 over 6, and then you put it back into this. Minus 3 into 10 over 6 whole square plus 10 into 10 over 6 plus 11 is 58 by 3, and that's the coordinate. And then we discussed earlier how to get minimum and maximum. The second thing is sketching the graph. So if we have this function x squared plus 6x plus 9, we can find the vertex is minus 3 comma 0. So what you do is you sketch a U shape, or it's called a parabola. The y-intercept is 9, as you can see, and then you just have a turning point at minus 3 comma 0, so this is the shape. Then you have minus x squared plus 5x plus 6, this as a vertex of 5 by 2 comma 49 by 4, and a y-intercept of positive 6, and because x is negative, the shape will be sort of reversed to u because that's a maximum point, and so that's the turning point, and then you have on either side going like that. Right, now third part talks about the discriminant, and essentially this is the quadratic formula, and b squared minus 4ac, which is under the root, is called the discriminant. And then there are a few conditions which can easily determine the number of roots and the number of points of intersection. So if your discriminant is greater than 0, we note that there will be two roots, because like the square root of any positive number, let's say 9, is plus or minus 3. So the positive gives one root and the negative gives one root. Now if it is equal to 0, we just know the square root of 0 is equal to 0. And so there will only be that one root, which is minus b over 2a. And then if it is less than 0, let's say minus 3, not bad, 1 second. Let's say minus 3, this has no real solutions. I don't think imaginary numbers are part of the syllabus, so we just ignore that and we just say the graph looks like this. So this one has 2 points of intersection of the x-axis, this is 1 and this is 0. The same thing with a line, so discriminant greater than 0 is 2 points of intersection with a line, 1 point and then 0. So we'll show that line one here in like an example. If you have the curve and a line, to find the essentially points of intersection, we equate the two. We then form one equation so that it's equal to 0. We find b squared minus 4ac here, which is 9. Since it's greater than 0, we apply this and we know that there's 2 points of intersection. You can do this with any given line and curve. Alright, now to actually solving quadratic equations, there's three methods. We have factoring, completing, sorry, the quadratic formula, and then we have completing the square. So factoring is very simple. Essentially what you need to do is get two numbers, x plus a and x plus b, such that a plus b is equal to this number and a times b is equal to this number. So a plus b is 2 and ab is equal to a plus b is 3 and ab is equal to 2. So essentially we can see 2 plus 1 gives 3 and 2 into 1 is 2. So those are values. So x plus 2 is equal to 0 gives us x is equal to minus 2. X plus 1 is equal to 0 gives us x is equal to negative 1. Second method is the quadratic formula, where you just plug in the numbers into the formula, simplify, and you get two values. Now, in an exam, you should probably look at the marking schemes to figure out how many steps you need to show, but I would recommend showing as many as possible so that there's just that chance where you don't lose marks. And then we discussed completing the square earlier. This is the same process, half, subtract that one, and so basically you complete the square, you take it to the other side, and then you just solve this like any normal equation you would. Instead of expanding this, you just take that to the other side, square root it, you get two values, take that to the other side, and then for the plus and minus gives you two values. So let's say this example, this is my method. Some people do it differently, but essentially what you can do is you can take this 2 here to give you x squared plus 5x plus 4, because 2 into 2 is 4. Factor that like a normal equation and then divide by 2 here. So 4 by 2 is 2 and 1 by 2 looks kind of awkward, so we can put the 2 as a coefficient of x to give us 2x plus 1, and then we can just solve these two separately. Alright, now quadratic inequalities, again somewhat simple. Essentially x squared plus 5x plus 4 is greater than 0. So we want, this is what the graph looks like, and we want anything above 0. So that's above this line, right? So first we factor it, and then you can see, so at negative 4, anything to the left of negative 4, which is essentially less than negative 4, is above the x-axis, and anything greater than negative 1 is also above the x-axis. So what you should probably do here, the algebraic ways involves some complicated algebra essentially, but just draw the graph and find the x-intercepts and the region essentially that's above or below, and then the your final answer will always involve these. Unless there's no x-intercepts, then it's just the entire graph or none of the graph, it's like the where discriminant is less than 0, so it doesn't intercept the x-axis. The same thing here, but less than 0, so it's just between this shaded area here, and so that's just like, you could also write it like this, um, but these two are equal. um, yeah, these two, the sorry, this and this are same. So, but this one is more preferred over this one. And yeah, that's it for this chapter. Thank you.